Morning guys, Bob Murphy again. Welcome to my presentation. Today we're going to be talking about Boyle's law, which is all about pressure and volume and how they change with depth. Why is this important to you? It's important to you because your customers, most of them running buoyancy control devices, BCDs, they've got some air in those BCDs. It's nice for you to be able to explain why variations in depth are going to affect that volume of air. It's also the reason that we breathe continuously, because this is the reason if we were to go up and hold our breath, this is the reason we could damage our lungs. Okay? So it's very important information. I've taken away the constants from the side of the board. I've assumed that you can work out pressure already. So let's get straight into some very basic calculations. My question first of all says a flexible container. Very, very important, this word. Always my flexible container is a balloon. If my question says inflexible container, that is not going to change, and I would draw a scuba tank, just to remind me that it doesn't get bigger or smaller. We're going to deal today, because we are changing volume and changing pressure, we're going to deal with a flexible container only. So first of all, we'll get our water. This is salt water. And we're going to take our flexible container at the surface, which obviously is 1 atmosphere. And my flexible container is 12 litres big. Just simply going to take it down underwater. If I take it down to 2 atmospheres, what Boyle said, he said pressure times volume is constant. So he said 1 times 12 equals 2 times the new volume. Don't worry too much about that, just worry about the fact that it's got half the size. So now the balloon, and it's gone down to 2 atmospheres, it's 6 litres big. If I take it down to 3 atmospheres from the surface, it's got slightly smaller again. It's now a 4 litre balloon, and at 4 atmospheres, it's a 3 litre balloon. And I always draw this drawing when I get these questions, because I can actually represent my balloon getting bigger or smaller in my drawing. If I drew all these balloons the same size, then my mind would probably get a bit confused during my question. It's nice to have a nice picture. And that's the simplest calculation I could possibly do. Let's do something more similar to what you'll find in your exams. Let's keep a balloon underwater for a moment. Again, we'll work in salt water. And this time, I have a balloon and it's 12 meters deep and it's 4 liters big. And I'm going to take it to 24 meters, so I'm going to draw it smaller, because it is smaller down here. And also I'm going to do is I'm going to take it to the surface to keep the maths very, very easy. There it is at the surface. Fantastic. So now that's my question. But not all my information is here. I need more information than this. I need to know the pressure. So I've got an easy 1 atmosphere here. I've got 2.2 atmospheres here and 3.4 atmospheres here. Fantastic. So when it goes up, how much bigger does it get? It gets 2.2 times bigger. If you need it, bring out the calculator. 4 times 2.2 equals. Okay, I'm happy. It's 8.8 litres big at the surface. Okay, so there it goes going up. So I'm going to put times 2.2. Now I'm going to take it down to here, and it's going to get smaller. How much smaller? 3.4. To get smaller, you must divide by that 3.4. So I've got my 8.8, divided by 3.4, and that says 2.588. I'll keep all those numbers for a moment. 2.588 litres. And now I look at my question, and it may say to me round to 1 decimal place, which will be 2.6, or 2 decimal places, 2.59. I think you'd agree, very, very simple. It's getting this much bigger, then this much smaller. Let me do one more example. This is very easy to do. I'll do another example in fresh water for you. Happy with that? And I'd recommend you draw this drawing for any of your questions. You can always go back and check. The classic is to forget the 1 atmosphere from the surface. You can always go back and double check on your numbers. Let me take that away. Let's go into fresh water. Let's this time take a balloon from 24 meters to 10 meters. So it's got bigger. And the same as before, we're going to first take it to the surface. Okay, again, all my information is not there. So the 1 atmosphere is the easy one. At 10 meters in fresh water, using the constants, I've got 1.97 atmospheres. I need a calculator for 24 meters. (24) divided by 10.3, 2.33. That's not quite right. Hold on, must add the 1 from the surface. 3.33 atmospheres. Now I have the information that I want. Sorry, I forgot to put the size of the balloon in there. Let's have a 6-litre balloon. 6 litres down here. Cool, let's take it to the surface. Take it round here, a long way around. So I must go 6 litres times the pressure. So I multiply by 3.33 to figure out how much bigger it's going to get. So 6 times 3.33, 19.98. I'll keep all those decimal places. So when it's on the surface, it's 19.98 litres. Looks about right, about 3 times bigger, a bit more than that. Cool. Now I'm going to take it down, and it's going to get smaller. How much smaller? This much. So I divide by 1.97. Take my 19.98, which is on my screen already, divided by 1.97 equals, and that's got 10.14 there. So there we go, 10.14 litres. Simple? I hope that is simple. Again, screenshot. The trick is with this is to practice. So you can go to your knowledge workbook and you can find the questions on this very, very clear in there what's going on. I hope that helped.